Hi, grade 7. This is the math lesson for 4-7, which is entitled Indirect Measurement. This is an awful lot like the similar polygon lesson, and hopefully this will make sense to you shortly. Imagine we have somebody who's casting a 7-foot shadow, and yes, they have no arms. And we have somebody else that's casting a 4-foot shadow, and they are 3 feet tall. 3 feet tall with a 4-foot shadow. And somebody else, we don't know their height, but they're casting a 7-foot shadow. How would I find the height of this person? I'd set up a proportion, and I would compare corresponding parts to corresponding parts. So these two would be corresponding, and these two would be corresponding. I'm going to go x over 3 as 7 over 4. Right? X is to 3 as 7 is to 4. I went big person to little person, big person to little person. And we solve for x. In this case, x would be, 5 and 1/4 feet. Or, if you wanted, you could change that to 5 feet 3 inches. But 5 and 1/4 feet would be a good enough answer for that problem. This next one's a little bit trickier because they have a figure inside of a figure. And the first thing I would recommend you do is you break the figure apart into two pieces. Do you see this smaller triangle that's 6.5 by 9? I bring that up here, and I'd rewrite it like this. And then I'd look at the whole thing the way it is now. See, 6.5, that's the corresponding part to h, and 9 is the corresponding part to 31.5. So my proportion would look like something like this. How about h is to 6.5, h, big triangle to little triangle, big triangle to little triangle. So I'm going to go 31.5 over 9. Now, excuse me. Excuse me, of course I would get a sneezing fit right now. But anyway, now we need to solve this. I'm going to take 6.5 times 31.5. I'm multiplying the cross products, and then I'm dividing by that remaining number of 9. And I get an answer that the height, h, is 22.75 feet in this particular case. 22.75. Okay, let's move on. This one's very similar to the previous one. The first thing I would do is I'd rewrite it by drawing out the short triangle here so I don't get confused. The short triangle is 8 by 1, right? And so now I see two triangles, 8 by 1, 50 by x. And I think about the corresponding parts, right? And I'd have 8 is to 50 as 1 is to x. We need to solve for x. What's 50 divided by 8, right? X in this particular case would be 6 and 1/4 when you do the math. 6 and 1/4 inches. Because 50 divided by 8 goes 6 times and 1/4. Okay, down here we've got another one that's similar to the previous two, but it's a little trickier. We're trying to figure out what this length is right here. So how do we do that? Well, I didn't give you the length from here to here, did I? I didn't give you the length of the small triangle. The question is, how long is the small triangle from here to here? Well, if from here to here is 20, and from here to here is 2, then this has to be the difference of 20 and 2, or 18. And we're trying to find x, so this must be x, right? So now I can get rid of that 2, I can get rid of this, and what we really have is one triangle that's 20 by 2.5, and another that's 18 by x. And these two would be corresponding parts, and these two are corresponding parts. So how about we go with something like, oh, where do I write this? Can you see that over here? Yeah, 20 is to 18 as 2.5 is to x. And now we're going to need to solve for x. So we're going to take 18 times 2.5 and make that divided by 20. And I get 2.25. 2.25. X equals 2.25 feet. X equals 2.25 feet. Okay, let's move on. This one's similar, but a little tricky. We got to think through and pay attention to these arcs. 2 arcs, 2 arcs, 1 arc. 2 arcs, 2 arcs, 1 arc. They mean something. They mean that theoretically these two angles are equal, these two angles are equal, and this angle is equal to this angle. I know it doesn't look perfect, but think of it that way. If I look at this 45, which is between 2 arcs and 1 arc, what over here is between 2 arcs and 1 arc? It's the 21, right? So this has to be corresponding to this. Now this x is between 2 arcs and 2 arcs, and so is this 10. So they must be corresponding parts. And that helps us to determine how we're going to write the proportion. I'm going to go 45 is to 21 as x is to 10. 45 is to 21 as x is to 10. And now I'm going to take and multiply 45 and 10 together and divide by the remaining number of 21. And I get an answer that's approximately, x is approximately 21.4 meters. We're just going to round that to the nearest tenth. Okay, here's another one that's pretty similar. This x is between the 3 and the 2 arcs. What number down here is between the 3 and the 2 arcs? Isn't it the 32? So x, I'm going to pair it with the 32. The 30 is between 3 arcs and 1 arc, and so is the 25 between 3 arcs and 125. So I'm going to pair those together. And so now I can go maybe 30 over 25 equals x over 32. Can you see that? Yep, good. And I'm going to multiply the 30 times the 32 and divide that by the 25. And I get something in the neighborhood of 38.4. X equals 38.4. No label because I didn't put any labels on the problem. Okay, what if somebody said a 6-foot tall person is casting a 12-foot shadow? Meanwhile, an unknown height of a person is casting an 11-foot shadow. Can you find the height of this unknown person? Hopefully you can see that this pairs with this pairs with this. So we've got 6 over x equals 12 over 11. And if I solve for x in this case, x ends up being 5.5. Let's go to the next one. Pretty similar. Do you see that the 25 is going to pair up with the x and the 75 with the 60? So I could write 25 over x equals 75 over 60, right? And if I do that and solve it, x would be 20 in this case. Finally, the last one. Can you see that 42 pairs with x and 14 pairs with 185? We could then write 42 over x equals 14 over 185. Oh boy, I can't do that one in my head. Let's see, 42 times 185 equals, divided by the remaining number of 14, and I get 555. Pretty big number, but that's the answer, 555. Okay, 7th graders. Hope this makes sense to you.